Okay, again, thanks for coming. My name is Ben Freckman. I'm the product portfolio manager for Eurotherm by Schneider Electric in North America. And today, what I'm going to try and help you guys understand is from our perspective, Eurotherm, Schneider Electric, how we're trying to fit into industry trends, specifically the Internet of Things. Anyone in at the Innovation Awards at one? Anyone seen any of those products? The ASHRAE community, I guess, comes together and does that every year at the show, which is pretty cool, so you can see different categories. But one of the main tenets was how are we fitting into this IoT or IoT trend, whether they're commercial or industrial applications. So I'm kind of want to break down a bit about how our core competencies at Eurotherm and Schneider Electric are fitting into that and how we're building for the future. So just start off with a quick, everyone's familiar with Internet of Things, right? I don't have to say it 300 times, buzzword away. But I just wanted to start off with a quick snippet from Gartner, and is that they predict by 2021 that 40% of companies will have an edge strategy in place, and that's a huge increase from the 1% they had in 2017. So you can see it's a high growth area, and what I mean by edge strategy, I'll show you here. So how we break it down in Schneider Electric is, maybe you've heard of EcoStructure or something along those lines. Basically, it starts with a bottom layer or components that are closest to the process. So whether that's in HVAC, which we're all here to talk and learn about this week, or in any other industrial applications, these are the products that are producing the data, right? So valves, motors, thermocouples, right? A couple of examples here. Tons of products out there on the floor today that meet this connected product spec. And then the next layer up is where the edge is, right? So the edge sometimes is misconstrued as the end, right? The sensor. So sometimes you might think the edge is the absolute end of the data generating structure, but the edge is really where the processing happens, where the control happens. So that's where things like PLCs, PID controllers, data management, that's all gathering the information that the sensors are providing, the motors are providing, the thermocouples are providing, and then acting upon it or storing that data and making sense of it, organizing it in some fashion. The next layer is what happens with all that data that's being generated by these edge devices, right? So you're thinking about the cloud here. How am I accessing things that are in my plant thousands of miles away, and all that information, how does it get processed from plant to plant and fed into my financial ERP system? Or, how is my supply chain, all that data being mixed together, right? That's done by apps and analytics, which can aggregate all that information together. And the core idea is that we want to make sure that as we're getting closer to the edge, more and more can be done by those devices. So sure, you can do all this super computations in big PCs in the cloud. However, if you're just controlling a small air handling unit, you don't want to have to pass that data all the way up through the cloud and back down to generate a simple control signal. So another core tenet of this is that you want to have security embedded in all of those processes, right? So you can limit access or restrict information flows so that they're filtering the right kinds of information from the connected products through the edge control devices all the way up into the cloud, right? We start talking about these huge data lakes and data pools. Once you start getting into managing too much or too large of information sets, the processing becomes somewhat silly to keep doing over and over, right? It's a huge processor or power drain. So we want to try and limit that type of processing to the devices that can use it best, and that's why pushing control to the edge is a big part of what we do and kind of our core competency at Eurotherm, specifically within Schneider Electric. Obviously, Schneider Electric, lots of different competencies throughout the company, but at Eurotherm, our kind of bread and butter is PID analog control or programmable logic control type applications. So what is kind of behind this general push to the edge, and why is that increase from 1% to 40% a big deal, and what benefits is it bringing to us? So as I just mentioned, processing at the edge, or where that source of information is generating data, eliminates latencies, right? Instead of having to push information up to the cloud, we'll actually look at an example in a little bit. I'm able to process that data even more quickly than pushing it through multiple sources. And also, it eliminates points of failure, right? If you have multiple connections and your big app or your cloud is processing that data, if any one of those points fails, there's a break in the system, right? You're maybe losing time-critical information or customer-critical information. So the more processing that you can do closer to the site where the data is being generated, the better it is from a safety standpoint, cybersecurity standpoint, and just in terms of processing time. It also helps to eliminate complexity, right? As all these data points are being connected, the IT people are freaking out because how do we manage our infrastructure, right? We've only planned for X number of devices, and now you're telling me every little sensor on every little device needs to throw data points to our cloud. It's just almost impossible for us to handle. So it helps to eliminate that type of complexity, so you can start to filter, right? We're not saying don't pass information up to the cloud. We're saying do as much processing as you can at the edge, and then that way there's less information to pass to the cloud to get more analytics done there, more artificial intelligence applied, machine learning algorithms, et cetera, et cetera. So how does this relate to what I'm here talking about, some of our products? The EPC3000 at its core is a single loop PID controller. However, as it pertains to this whole edge processing, it kind of entering the market and being able to push more of the processing to the device itself. So, right, typically if you think about an on-wall thermostat 15 years ago, on-off control, it goes above a certain temperature, clicks on, below a certain temperature, clicks off, or vice versa, depending heat or cool, right? What we've done is start to embed more functionality, but also give it the ability to pass information via multiple protocols, right? This week is probably more about BMS and that larger building management system environment. So we're talking about BACnet, IP or MSTP, depending on the network structure that you have in place or transition that you're trying to work towards. But we also deal with standardized protocols such as Modbus and Ethernet IP for PLC type integration. So it's more of a vendor agnostic, trying to work with lots of different protocol or communication types in order to get all that information together while still doing the processing that's required by that edge device where it can, and limiting that kind of functionality to that device itself. So let's take a look at a quick example and a reason for it, right? I think a lot of people understand that this whole Internet of Things push is more towards a way to prevent unplanned or unscheduled downtime, right? Something fails, we'll kind of look at a maturity curve here on the next slide, but generally, right, something breaks, oh, we need to fix it. As you move up the maturity curve in your asset performance management kind of plan, you're looking at preventative maintenance, right? So let's try and figure out when something's going to fail so that we can plan to have that downtime to fix it before, this is a huge shutdown, right? Think about like a hospital losing its sanitary water or sterilization procedure from a boiler tank, right? If something shuts down, that boiler is inactive, how are they going to be able to process all these patients, keep that safety that's intrinsic to, the core of the hospital going, right? And so as you start to move up the maturity chain, you get into condition-based. So, something went wrong here. My mechanical part has reached a certain point in its lifetime, right? If it's a sensor, maybe it's based on time, and you kind of average out the days. You can say, okay, at about 6 months, these motors are going to fail a little bit. They're going to take a little bit more power to deliver the same output. The previous presentation was looking at being able to deconstruct the materials so that more output could be gained from less material input with the same amount of power as well. So a net positive result. And then you keep moving up, right? Predictive becomes prescriptive, so that there's no more of these unplanned downtimes, no more shutdown time. You're getting into a cycle of always on, information all the time, always connected, right? So further increasing that efficiency and that ability to be always on and always generating an output if that's what's required. Here you'll also see some of the use cases. Maybe I'll highlight them here for you guys. Get my laser pointer. All right, so you can see at the top of the list, what are people using IoT, or what are some of the use cases that is driving this push to digitization? And remote monitoring and energy efficiency is up there as well, right? So people want to be able to control their process at the edge, but if you can start working in things like energy efficiency and energy monitoring, you can start to use those to regulate, and even in some cases, right, charge your customers based on input or output, based on the work that they're creating in their process and what they're paying for, right? A lot of the innovation awards today actually look to reduce the energy usage of many of the different processes. In fact, the winner was an air handler unit that reduced the amount of outside air for a whole building HVAC system to use, and it improved the air quality of that air that was being used inside the system, right? So it reduces the necessary size for that whole system, so creating efficiencies there, while also increasing the indoor air quality of the air that's being circulated inside. So here, just a quick look at a typical BMS layout, right? We have a couple different layers. So down here are our edge devices, and they're connected to these connected products, whether, here we have a couple different pressures. So in this example, we're using the EPC3000 as perhaps a heat exchanger, monitoring the temperature and controlling some pressure valves to a heat and hot water system. But we also have the NanoDAC, which is one of our data monitoring devices. So the NanoDAC is pulling all that data, all the input, feed water temperature, condensate output, right? All these variables that you can use to generate a energy consumption algorithm locally. So you can start to make decisions like that, like when we're getting above or below a certain amount of efficiency, let's turn on another fan. Let's bring in another source. Let's use more municipal water input, something along those lines. But then also, because it has BACnet protocol implemented within the NanoDAC, it's pulling all that data and pushing it up to the BMS as well. So the BMS has full visibility, but you don't want your BMS to be controlling all the points that it has to between all those connections, right? Because I'm bumping up 2 levels. If, say, I'm trying to control the valves that these EPC3000s are controlling pressure for, I don't want that latency for pressure, such a fast acting process, to be controlled by something 2 layers up in the network configuration, right? So giving edge devices the ability to make that control happen faster, closer to the process, but still providing all that data so we can show over time in the BMS, in some of these apps and analytics that are in the cloud, of, in the winter months, we're operating at 75% efficiency. How can we improve that and relate that data to the summer months when we're actually operating at 85%? What are some of the changes that we can make, or is there anything we can do to improve that energy efficiency? And here's just an example of some of the internal processing that makes that happen. So depending on the variables that you're using, pressure, temperature, humidity in some cases, whatever variable it is, right, they all get fed into these energy calculations. In this case, I've just highlighted boiler efficiency, but it can be anything from BTU calculations for a heat exchanger, for a typical HVAC system, things like that allow you to show all the information on the edge device, but then feed it up into these algorithms in the cloud that are doing the analytics that don't require such quick processing time. This is more of like the deep learning or machine learning type things that are happening with all that data and information that's been aggregated. So hopefully that makes sense as far as pushing more of the efficiency calculations and more of the processing closer to the edge, allowing the edge products to make those decisions, make those control applications happen faster, while still being able to provide the information to the cloud that's being generated, so that future decisions can be made based off that data. Thanks for coming. We've got a couple minutes for questions, 10 specifically. That actually lasted 20 minutes exactly, 5 minutes left. Any questions? Thanks for coming. No. Great. Well, thank you guys. And come by the booth.